So I will continue the lesson by introducing you to the concept of version control, and then we will also go through in practice how to use Git in the Jupyter Lab environment. So you will need still the CSC notebooks during this part of the lesson. So let's go. Maybe I can get a thumbs up from Dave or something to know that everything is in order. Yes, there it came. All right. Okay, so version control, what it is and why are we spending time teaching it during this course. So you might be familiar with the situation that you have your documents folder or some course project folder with files with maybe unclear file names and maybe separate versions of the same thing coded somehow in there in a way that you understand. But if you would go back after even a week or after a year, you have no idea what you've done, what is the latest version, and then you're just kind of going to do it all again from scratch because you haven't really marked down your versions and documented the process. And that's fine. I have a very messy documents folder. I use my desktop as kind of a workspace. So that's nothing to be ashamed of. Of course, this can also happen if you're collaborating with people. So you might get some feedback. You think you have your final version of your master's thesis or course project, but then there's changes. And then at the end, you're again confused. What was the latest version? And then you might make it worse. You might add changes that make it worse, and you would want to go back to a version from a week ago, but you have no idea anymore where to find that version. So in short, version control helps us to manage and keep things organized by recording changes to a file or a set of files over time. And then this would allow us also then to go back in time if needed and to revert some of the changes. For example, our web pages we develop using version control, and version control also then allows you to have parallel versions of the same thing to kind of develop it in parallel and then finally combine the kind of master version of your project. So that is version control in a nutshell. And this image again illustrates that each time you add, for example, a line into a text document or a new line of code into your script, then the version control keeps track of these changes and will be able to revert them if needed. And in practice, there's again a broken image link. We will be using Git, which is then a version control system or version control software developed by Linus Torvalds by Curiosity, who studied here in Kumpula campus. And Git is the piece of software that then takes these snapshots. So in certain moment of time, the state of all the files in this project, Git keeps track of those changes, and then that kind of version history will be stored using Git. And Git is a distributed version control system, which basically means that if we have our files on our computer in a Git project, and then we have the project over at GitHub, those are kind of independent. So, for example, we don't send everything to a centralized server, which would then have the main version and only from there read. But we can have multiple kind of clones of the same set of files. And then logically, GitHub is related to Git, so the version control system Git. But basically, GitHub is a hosting service then for these Git projects or repositories, and it also then allows for collaborative software development, and also is often used for just documenting your workflow, documenting your code, documenting your process. And for researchers, this is great because you can, well, share your code. If you publish a journal article, you can share the analysis code over at GitHub. And then also see what other people have done, take somebody else's code and try to replicate the work, which is of course key thing when doing science, that it should be replicable. And for that, you need to have the process explained. And for students, master students, if you want, you can document your master's thesis analysis workflow in a GitHub repository. As you saw in exercise 1, there's often a README file, kind of a cover page, and then these one or several script files or Jupyter Notebook files in there. But as I mentioned, also then the version history is saved on GitHub, so you can go and browse backwards. And especially if you're collaborating with somebody else, it's very handy. So I can go and see what changes Dave made to the website before I start updating from my behalf. So that's version control, Git and GitHub in a nutshell. And next we will go and look how to do version control in practice using Git. There we go. So there's a lot of text and definitions on this introduction to version control page. Feel free to read them. We will continue here on this Meet Git lesson. From the web pages, I'll explain a bit in detail the main concepts, and then we'll get hands-on working. So how do we do version control, or how do we use Git in practice? And there are these basic steps always when using Git. And from the perspective of this course, we often, when working with the exercises, so you have some exercise kind of project repository already over at GitHub, and we will take a copy of that and start working and tracking our changes, and finally synchronizing our changes back to GitHub. So the basic workflow consists of cloning, then start working, adding changes, kind of putting it all on the table and editing, and maybe you can revert the changes. Then when maybe you have solved problem 1, you commit changes, so we make a snapshot, and then finally we push changes, so we synchronize changes from our computer back to GitHub. So these words clone, add, commit, and push will be important to understand in order to know what's going on. And in practice, during this course, we recommend that you use a plugin that is available over at Jupyter Lab. I'll show it in a bit. But then maybe the traditional way of using Git is from the command line. So at the end of this document, we also have a brief summary of how to use Git from the command line. All right, so still a bit more on the concepts and the basic workflow. So I mentioned this word repository many times. So what is it actually? In Finnish, it would be säilytyspaikka, so a place to store things, mainly place to store files. It can be image files, text files, script files, of course, as we're doing programming. So often we have a repository, which is a well-defined project. For example, an exercise is stored in one repository, and then we track the history of this repository and files in there. So on your own folder, on your own computer, a repository is often a folder with files in it. it's the same thing. And then using Git, we turn it into a Git project or a Git repository. Then we have this image to illustrate the main workflow of synchronizing files between GitHub and then your own computer or the cloud computer, so CSC notebooks. So we can have the repository on GitHub, which is often the starting point during this course. And it's there, it has maybe one or several files. And when we start then working on our own computer or at CSC notebooks or binder, we take a copy, so we clone, we take an identical copy of the contents to the computer we are working on. And that action is called cloning, and the command is git clone. So you always start working on the exercises by executing the git clone action. Okay, and then once we have our files on our computer, and then we start to work on the exercise, solving the problems. We create commit changes, so we do the snapshots. I'll explain that in a bit. So once we want to synchronize our changes from the local computer again to the remote repository, so in our course it's always on GitHub, so then we can push the changes, and then vice versa. If we want to update our local repository with changes in the remote, so then we pull the changes. So this is related to the fact that Git is the kind of distributed version control system. So it's always good to pull changes from the remote repository before starting to work locally. It shouldn't be such a problem now that if you have your kind of individual repository, but except, for example, if we are working with Dave on the same course web pages, it's better for me to first pull the latest version of the web page before adding my changes, so that we accidentally, for example, don't edit the same line. Okay, so this, I hope this image helps you to capture what's going on a bit later than when we go hands-on. Then this figure here is everything that happens within kind of on your computer related to the local repository. Is there a question? Madeleine, or did you just unmute your mic? No question. Okay, I'll continue. So then the actual version control workflow on your computer, or you could do these things also on GitHub. So it's the kind of remote repository. But on your local computer, we start from here. So you have your workspace, you're on Jupyter Lab, you see all the files. You could add new files, you can edit the files, solve the problems, maybe fix things. And once you're happy, like now I solved problem 1 or I fixed a bug, then you add your changes to a staging area. And this middle part here might be a bit difficult to understand at the beginning, but it will become more useful, especially when we have many files and we only want to commit some of the files. But we always add the files we want to record in version history. So the files we want to keep first to the staging area. And once we have a clear set of changes, for example, solved problem 1, then we commit them. And commit comes always with a message. So then I would, at the commit stage, say solve problem 1, and then that becomes a permanent snapshot. And all of this happens on your computer. Nothing has yet gone to GitHub. And once you're here, then you push the changes. Okay. So for some of you, this might be the first time you hear these concepts: add, commit, push, pull, clone. So don't worry, we will be repeating this each week for the 7 weeks and 14 weeks for those who continue with automating GIS processes. So it needs a bit of repetition, but at the end it's rather logical workflow. So now that we are familiar with the main concepts, let's start working in practice. And for that, if you want to follow along, you'll need two things. So CSC notebooks, Jupyter Lab, and then your exercise 1 GitHub repository. So you might have it already open, but if you don't have something like this open, so the Jupyter Lab instance from CSC notebooks, and we will start using this Git plugin that you can find from the left-hand side. And then the second thing you need to have is your personal exercise 1 repository over at GitHub open. And we could now, I think it was nice last time, these little green check marks. So once you're kind of ready to go, please let me know by clicking this yes button in the participants list. So you can, you probably can't see it on the screen, but if you go to participants, you can see your own name, and you can, or at least at the bottom, you have this yes button. So I'll wait for a little bit so that everybody's kind of ready to work and you have your Jupyter Lab open and your exercise repository. And this is a good time to remind yourself about your GitHub password, which you will need now that we start working. Okay, 39, I think I will move on. So as explained, the basic workflow starts by cloning a repository before we actually start working with the files. So we have a repository. All of you have launched the GitHub Classroom repo for exercise 1. Mine looks like this. I haven't completed exercise 1, I only have a draft of it, but you should have a README file, exercise 1 file, here on the website over at GitHub. So in order to clone or get a copy of this repository on our own computer and start working, we can click on this code button, and you see clone with HTTPS. I can't find the clone repository. So maybe Dave can help, but if you should be able to go to Geo-Python 2020 and your own. If you can't see that, you can also go to exercise 1. You should be able to see that, and then you can, I think you can, from here, you can then go to code and use this link. But otherwise, if you have your own copy of the exercise, then copy this address here. You can press this button, or then Control C on a Windows computer copies it. Yes, okay, great. Everybody's with me. So I'm still on the website, exercise 1. Under the code button, you copy the link to your repository. So it's the URL for the remote repository we are copying. Okay, you can do that also a bit later. So now we would want to have that those files here in Jupyter Lab in order to work with the exercise, or maybe give yourself some feedback. So we have these over at CSC Notebooks, we have things organized into separate folders. So I suggest you first double click on the exercises folder that we are over there. And this would be the logical place then to clone your exercise files. So in the root folder, double click exercises. And now you should see that you are located in the exercises folder. Okay. And at this step, we then clone the repository. So in the Jupyter Lab, we have a plugin for Git, which helps, enables us to do this by clicking on this graphical user interface. There's different options. You might start from scratch and create a new repository, but during this course, we will always start by cloning the exercise repository. So we click on that one. And now if you have the link copied, I'll do Control and V on my Windows computer. So I get this link which ends .git, and then I clone it. And after that, of course, as it's a private repository, so I need to provide my credentials in order to access it. So you wouldn't be able to clone my repository. No need to save any passwords here. And then finally, you should have the exercise folder visible in here. And maybe again, I'll now clear these, I'll clear the check marks. So once you manage to clone your files, please click on the green check mark so I know when I can then proceed. And if you have any problems, please ask. We can then see a bit how we can then start interacting with the version control system. So I'm still now in this file browser. I'm now in the exercises folder. And if I try to click on this Git plugin, it tells me to clone things again or something. I am not in a Git repository. This exercises folder is not a Git repository. Okay, somebody asks what I did. I'll show it in a bit again. But if I double click on this one and then click on this Git tool, then I see a different interface where we will continue. So over at GitHub, I was in my personal exercise repository. I went to code, clone. You can click here. It copies it on your clipboard. Then I went back here, and then you can Control V in this. When you're in the exercises folder, then you clone a repository. Control V, paste it here, and clone. I won't do it again because I already did. So I'll continue here then with the Git workflow in our local computer or the cloud computer. So I hope you can see something like this. Once you manage to clone the repository. So now we will start working. And how does that happen? So we take a file. Maybe you all could open the readme.md file. So this is a markdown file. It only has markdown text in it, as the Jupyter notebooks have markdown cells and then code cells. And here, we could maybe scroll, clone a repository. Maybe I'll show it once more. So you have this Git tool. Click on it when you're in the exercises folder, and then click clone a repository. Then paste the link, and you should have your files. But those who are ready could open your README file. So the kind of front page of our GitHub repository thing. So the README file contained the exercise instructions, and hopefully within the next week you will get some short feedback from the course assistants, but you could also of course do some self-assessment. So these two hash signs format it as a title, kind of second level title, and then you could write some self-assessment now from the future that I did very well, CSC notebook. So you can also blame some of the tools if things didn't go well. So edit this README file, write a couple of lines. It doesn't matter what it is, but we can take this opportunity to reflect on our learning process. And once you're done, remember to save the file. So I now press Ctrl S, which saves the file. I think there is also some button. There should be a button to save, but anyway, at least Ctrl S saves your changes. And after doing some changes, we could again check what is the status of our Git repository. So especially when using Git from the command line, Git status is one of the most common commands we would use. So it's always good to every now and then see what files have I changed, and where am I at? Have I committed my changes, and so on. So maybe I'll show from here. So after you have edited a file and saved the file you edited, you should see the edited file under changed in this Git tool. So Git knows that you have changed something, but we haven't yet kind of added these changes to the version control system, right? So there's now one red X. Maybe Dave can go and help out. Okay, maybe I'll, yeah. Okay, so edit the file, save your changes, and then check the status of your Git repository. And then remembering the kind of flow chart at the beginning of the lesson. So we are still kind of in the messy workspace. We haven't added the files to the middle section, which is the staging area. So we need to kind of queue up the changed files for the next snapshot, so for the next commit. And this can be done by adding the changes. So I have now edited the file, saved my changes, and I can see it in here. And if I hover over readme.md, I can find this plus button in here, which says stage this change. I click on that, so it moves up in the process. So it's now in the staging area. And maybe I again clear the check marks. And please press on the green button if you have managed to edit a file and add it to the staging area. So you can have the buttons visible after you have changed something in there. Okay, I think most are with me who were with me with the cloning part. So now we have done git add, basically. And the next step is the commit step. So now we want to be sure that the changes we made, we're happy with them. Of course, we can go back in time also later. But committing changes then requires a bit more effort. So here over at Jupyter Lab, you can see this summary of the changes made box below all the files. And then we should add a commit message that describes what we changed. And what did we do? Added self-assessment. So that's quite a self-explanatory commit message. And you could add details in there, but often a short one-liner is enough. And then if we commit the changes, we need to provide some details. This doesn't really matter, but you can use the same information you provided to GitHub. And then you should see this green box, committed changes. And now you can see that kind of the working tree is clear in here. And where did the changes go? Well, they are on the history tab. So now you can see that I have last done 18 seconds ago a snapshot, added self-assessment. An hour ago, I added a draft for my exercise, and I initiated this repository sometime yesterday evening. Okay. Maybe we have time to add some more changes. Maybe I assume all of you have done the survey, so we could delete these 2 lines from the top of the README file because the survey will be closing today, so we don't need it in there anymore. I haven't yet saved my changes. I'm just demonstrating this now again in case somebody didn't follow. I saved it. It's again, Git knows now that I changed something. I add it to the staging area, and then I give a commit message, removed outdated info, for example, or removed the survey link, and commit. There we go. And now that we have done, I have done now 2 commits. I have them still here on my computer, and I would want to then push these changes to GitHub. So I'll show that now, and then I'll ask once more if there's somebody stuck or if there's some trouble. So the next, yes, maybe I'll skip that for now. So synchronizing our changes, basically pushing our changes, but also pulling changes from GitHub happens in this tool by these kind of cloud arrows. And it's good practice to always pull before pushing. Now it's unnecessary, but you might save some trouble later on if you always press the pull button before you push. So over at GitHub, if we press the down arrow, you need to fill in your details again. Okay, we didn't get any new changes because we haven't changed anything over at GitHub, but that's how you could pull new changes. So now we are ready to push our changes to GitHub. From here, okay, and if you remember your password, you can go back to GitHub, refresh the page. So now you should see your commit message here related to the file you changed. So my latest change is removed outdated info. So that is the latest snapshot. And actually, indeed, I can't see the link there anymore. And at the end, I have my self-assessment here at the bottom. So maybe once more, if you can give me a thumbs up by pressing the green button, so I know you were able to do this thing. So the same thing would go then if I would add a new file or add changes to my Jupyter Notebook files. Then after each major change, you commit them, so you get them to the version control history in here, and then you synchronize the changes to GitHub. That is it in a nutshell. There's still one red arrow. Maybe Dave can handle that. There is a way not to have to type in your username and password all the time, which is, there's instructions for that. I'll show it here. Don't worry if you are not able to do it, but if you want, you can copy this command, and over at Jupyter Lab, open a terminal window, and then paste the command in there. So at least after one time you insert your information, then Git will remember who you are. But this is extra. You don't have to do this if you don't want to. And you're welcome to go to the exercise sessions to fix this thing for you. So you need to repeat this for each instance. I can't see any questions. Please give me a thumbs up if you were able to commit the changes. Maybe I will show that one more time. Once more, I do a change, activate the Git plugin. I save the changes. I add the changes once I have the file under stage. So on the staging area, added a comment, could be also a commit message. I commit this snapshot. I can see it from here, and then I push the changes. And after pushing, I should see whatever changes I made after refreshing the page over at GitHub. Python is fun. So there was one more. Okay, one thumbs up. So that went pretty nicely now that we are using the plugin. Last year we did this all on the command line, so there were some, maybe a bit more hassle. So that's, at this point, this is all you need to know about Git and version control. Of course, there is much more you can do with Git, and there are kind of problem situations you might end up into. But if you encounter any issues, then always don't hesitate to ask. Maybe I'll go once just to kind of make sure you remember these words. So we started by cloning, we synchronized by pulling, then we added files, we committed files, and finally we pushed the changes. So that's it. Those are the most important Git commands. I will spend maybe 2 minutes for those interested. We have this Git from the command line section at the end. So feel free to use Git from the command line or practice how to use it if you want. For that, you will of course need to know the basics of using the command line and the terminal window. So here we have some most common command line commands you might need when working with Git. So listing files in a directory, changing directories, and so on. And in short, you might have to configure your details, so all this information that we provided using the interface. And then basically, this is the list of command line commands for repeating what we just did. So git clone, URL, git status would show where you are at, git add, file name, git commit, message in parentheses, git pull, and git push. But naturally, then you might have to read some error messages and so on. So feel free to use Git from the command line as well. And there's this nice sheet available online by GitHub Education with kind of a bit more extensive list of Git commands than what we use today. So we hope you get excited about using it and also adopt it to your other workflows, such as when you're working with your thesis projects or other research. There are some notes about working with remote repositories, checking your settings. Branching is a powerful tool in Git and GitHub, which we won't probably use so much in this course, but good to be aware of. For example, we have a development branch for our website, not to have always push the changes to the websites if there's typos and stuff. So branches is good. You should know that there are branches which are kind of parallel versions of the same repository. And then maybe if you get into trouble, so merge conflict might be, I think some of you might encounter a merge conflict during this course. So don't worry. And best thing to avoid these conflicts is indeed to pull before you push. So if you do that, you probably won't end up in a conflict situation. But if you do, then we might have to solve those issues case by case. So read the error message, ask for help. And if nothing else, you can of course do what we did during week 1. So you can download if you have worked on an exercise, you can download it on your computer and upload it to GitHub manually. So the most important thing is for you not to lose any work you have done. So maybe Git is sometimes something like, ooh, so cool to use version control, but how do we use it? It's not so complicated, but at the end you can, as the comic says here, you can delete everything and clone it again if things get messy. So that's it. If you have questions, please ask, but I think it's now time for me to pass over to Dave to talk about motivate you to pair programming and maybe mention the good coding practices. And of course, version control is already a good practice in software development.
Yeah, thanks, Woko, for the nice introduction to Git and using GitHub and this plugin and things. I have 3 simultaneous private chats going right now, so I'm sorry to those who I'm chatting with. I have to pause our discussion for the moment.
Yeah, maybe pending issues, you could repost your issue to Slack, so it won't be lost after this Zoom session ends. And indeed, go to the exercise sessions tomorrow and Thursday to get this workflow rolling.
Yeah, there are questions if you have like questions that you think could be addressed by all of us or that could benefit all of us. You can of course ask those in the public in the chat, but if you're having individual issues, we can try to get back to you individually once we finish with the group. Or yes, as Woko said, Thursday and Friday at the exercise sessions, that's pretty typical to spend some time getting everyone up and running with Git for that. So yeah, again, I will continue with those in the chat in private once we wrap up here, but maybe Woko, could I ask you to stop sharing? Yes. And I will share my screen like so. And I'll go back here to our great, off to a good start. Maybe my web browser is going to be a bit problematic here. I may have finally reached the threshold of having too many tabs open. All right, let me see if I can get another web browser working here. Yes, that'll work. All right, so we are going to be working in pairs on the exercises for the course, as Woko mentioned, and I think perhaps it's worthwhile to say something about why we're making you do this. There's actually a couple reasons for why we might want to have you working in pairs on the exercises. One of them is the fact that, of course, we can't be in classrooms at the moment, and so the normal working environment where you would have lots of other students who you could talk to and who you could ask questions to, that same environment doesn't really exist at the moment. And we want to try to make sure that you feel like you have support from other students in the group while learning to program in Python. It's important to not let yourself get too demoralized when you're learning something new like this, because there will be some times where, like, you have these moments of clarity, and all of a sudden you understand something that's been confusing you for some time. So why pairs? The reason for doing the exercises or suggesting that you do the exercises in pairs is not something that's entirely new, and it's not something that we've kind of come up with on our own, but paired programming is actually a technique that's been used for years now in a type of software development called agile development. And it is meant to be a way to be able to do, basically to be more efficient in programming. And it kind of works for experienced programmers that if they pair together, they can get work done perhaps more quickly than either one could do individually. But it also works nicely for new programmers. The idea in practice is that one person basically has their hands on the keyboard, they're the driver, and they're typing things in as they're working on the code. The other person in the pair is their navigator, who's in a physical setting would be looking over their shoulder, but we'll talk about how that might be able to be reproduced online. But the navigator is responsible just to kind of monitor what's going on, make suggestions for things that could be done in the code. And a big one is just catching little typos, catching little mistakes that you don't notice when you're the one typing that can end up consuming time when you are trying to figure out why your code doesn't work the way you expect it to. So by working together with one person basically monitoring things as they go on, you'll both learn from one another. The person who's the navigator should be active in giving suggestions to the person who's the driver. And of course, the driver will be taking these suggestions and trying to work on the exercises. So how we're going to do this on our setting here is that each week we're going to have one person in the pair designated as the driver. So first off, as mentioned with the survey information we're collecting about your previous experiences, we're going to use that to pair you up. So you will have a partner, and your partner and you will alternate each week which one of you is the driver. For the first week, we might, for this exercise number 2, we will inform the drivers who they are, and then their partners would be the navigator, and then they just would switch back and forth in alternate weeks. The driver will have the responsibility for cloning the GitHub repository. So that's one thing that the driver should do, and will also be responsible for the final version of the exercise that is graded. So we're only going to check for one of those copies of the exercise, and that is, we'll know who the drivers are each week, and we're going to check for their copy of the exercise to be the one that we would grade. When you're working, the driver is going to be the person who would have the exercise open on their computer. So they might have CSC notebooks open on their computer, and then they'll arrange for some way for the navigator to be able to view their screen. Now, if you happen to be partnered with someone and you're like sharing, living in the same place, or somehow easily sharing your physical access to the same computer, there's nothing that says you can't do this in person. Of course, keeping appropriate social distancing practices in mind as they may apply. But otherwise, you can also do, just like we're doing in our Zoom lessons here, the person who's the driver could create a Zoom that the two people could join and share the screen so that the navigator can see the driver's screen. The driver is going to be the one writing the Python or Markdown code, and the navigator is going to be following along, again, making suggestions, corrections, ideas, and otherwise just trying to interact with the driver. The driver types in something you don't understand as a navigator. All you do is just ask and say, like, why did you do that? I don't understand that. And vice versa. So that, you're both maybe going to approach solving the problem a little bit differently with different mindsets at the beginning. And in the end, perhaps you'll both understand what each of you are thinking about how to solve a given problem. As far as the driver is concerned, you've got the responsibility not only of modifying the code, but you should also be making commits to GitHub with some regularity. So anytime you kind of finish something, you should make a commit to GitHub. And the navigator can also be responsible for reminding the driver to do this so that you don't go all the way to the end of the exercise and just when you're finished, you run out of time on your CSC notebook session and then lose all the work that you've done. Or something like that, or your binder dies and then you lose your work. And as mentioned, at the beginning, the driver basically is responsible at the end to make sure the final version of the exercise gets committed to their GitHub repository, and that's what we'll check then. So our hope in doing things this way is that you will be feeling like you have a little bit of support that you'll be learning along with another person, and that maybe also in this way you spend a little bit less time being stuck when you're working on the exercises. And I do hope as well, and I think Vuoko and the other course instructors and assistants feel like this is actually something that can be fun, and it can be a nice way to learn from one another if you're open-minded about it and you're willing to jump in. It's a real-world coding practice. People use this, and this is something that is used for good reason. And it is a sort of an efficiency thing that you might kind of groan when like, oh, we got to go, be in groups and do a group assignment, and my partner never comes online and blah blah blah. I get it. We've all been there and been in groups where it's been frustrating to work together, but I hope that that won't be the case in this situation with just having the pair, that you can rely on one another and that you can learn from one another. So that's basically the idea behind why we're doing things in pairs and how it will work in practice. You can find this in the why are we working in pairs thing on lesson number 2. There's a few final notes down here that I just will point out. Again, we've mentioned about the driver's GitHub repository being the one that would be graded. As the navigator, you're welcome to make a copy of the exercise in your own private repository if you like. If you want to sort of work with the driver to finish it, and then you want to go through and practice on your own private repository, you can do that. And if the driver wants to have a version of the exercise to do on their own, again, just for practice, let us know and we can tell you some things about how to make a copy of the exercise folder to your, make a duplicate copy that would be able to be worked on. The driver can also have the possibility to add the navigator as a private collaborator on their repository in GitHub. I think I would discourage you from doing this, even though it's possible, because it's in working in this paired programming idea. I think it's best really that the driver is the only one committing changes to the code. We may experiment later on in the course with having a little bit more open-ended collaborative kind of coding thing, but at least for the first exercise, we'll do it this way, or well, exercise 2, first one is pairs. And again, this is an experiment for this year, something new that we're trying, and we'll be collecting feedback along the way. So we have an e-form that will allow you to give us feedback about how the exercise went. And if there are things that are like a problem or painful to deal with, then we can address those based on the feedback we receive with the e-forms. So, any questions about that? Okay. If not, I don't know, Vuoko, did you want to say something about this exercise 2? Or shall I?
Yes, go ahead, Dave, please.
Okay. So exercise 2 is not quite ready for you guys just yet. There's 2 reasons for that. One, when we open the exercise up, we would prefer to do it once we've told you who the pairs are. And 2, we're making some last minute changes to the exercise and realized there were some issues that needed to still be resolved. So we're working on that, and we should have exercise 2 available at the same time that you get the information about who your partner will be. And we will distribute that information to you on Slack, I suppose, so that you can then know to get started. So the delay won't be long, and we should have the exercise ready by the end of the day today, but it just might, it's not quite ready yet for you to get started working on. The existing version of the exercise, it is possible to go take a look. So if you're on the exercise 2 page here, and you see down here there's this template repository for exercise 2, you can go, no, you cannot go there. So that's not working yet either. So anyway, as you might imagine, exercise 2 is going to cover lists and interacting with lists using index values and things like that. And we will make that available to you shortly. And hopefully in the exercise sessions, we can also ask that that perhaps the assistants could give just a brief introduction to the exercise for those joining in there so that everybody knows what things are, what things are about for this exercise number 2. So sorry about the delay. I think in some ways it's actually good that you get this at the same time. You can figure out who your partner is so that we can synchronize things nicely that way. But you'll see exercise 2 soon enough. And maybe I'll leave it at that. So that takes us to the end of the lesson for today. In what is somewhat remarkable circumstances, we have finished even a little bit early. And I don't think, correct me if I'm wrong, Volko, you didn't say anything about this good coding practice.
Yeah, I didn't cover it yet.
Okay. So I'm just going to point this out to you. You'll see these GCP things in our lessons, these good coding practices. And for instance, if you went to lesson 1 and looked at the good coding practice there, you'll find some information about variable names and choosing good variable names. There's also a video about this good coding practice. So if you were to click the link at the top, on the overview page for lesson 1, there's now a video down here at the bottom that goes through this good coding practice. It's, I think, 7 or so, maybe 8 minutes long, kind of introduction to these good variable names. Just in case you hadn't noticed that that was there, you can find that on the lesson 1 overview page. And the same thing will go for lesson 2. I'll record the video for good coding practice 2 and put that up in the next day or 2. The good coding practice itself is about describing your code, and I won't spend any time really going through this, but it's basically about how to add comments to the code to make your code easier to understand, to remind yourself about how some parts of the code work, and also about adding markdown text, which is one of the powerful things in the Jupyter notebooks, that you can have this mixture of nice, rich formatted text with code cells together. So you're welcome to read through here, and you'll see some different reasons why we think adding code descriptions, which is the general term we're using to talk about comments and markdown, why adding that stuff to your code is a good idea. You'll also see that some experienced programmers might tell you that you shouldn't have to comment your code because you should be able to understand it just from looking at it. But that's not how we're going to approach things here. And so yeah, please take a look through there. You'll see some different styles of comments and other things related to this topic. And you should also soon see this video for the good coding practice number 2 up on the lesson overview page. I would say roughly in a day or so. But yes, I think that's maybe it for today. Vuoko, I don't know if you have anything else you'd like to add?
Yeah, no, nothing, just that to remind you what was the topic of today: lists, indices, Git, GitHub. And those you will be practicing in the exercise together with your coding buddy, which we will let you know later on how we grouped you via Slack. So by tomorrow's exercise sessions, you will know how this pair programming will be organized. Yeah, and maybe another thing, there's some pending chats. So with those students, I can stay here for another 15 minutes and resolve the things that are on the table, so everybody is on the same page.
Yes, same goes for me, that I will respond now to the chats I've been neglecting. And so if you have questions still, even if you haven't asked a question yet in the chat, you are welcome to stick around and ask questions either to either myself or Vuoko privately, or if you have a general question, you can also ask that in Slack, as we would encourage the general questions to go there so everyone can see the answers. But I think that's it for today. So thanks again to Vuoko for a very nice overview of using Git. You guys will get a hang of it in not too long, and I think you'll find out that more than once in your life, if you start using Git, it will save your butt more than once. It's definitely an experience I've had where I thought I had blown away an entire directory, and then thankfully had committed my changes to Git and not lost all the work I had been doing. So it's worthwhile to learn, even though it might take a little bit of time to get used to interacting with Git and GitHub. But with that, we'll see you in the exercise sessions Thursday and Friday. And if you have any other questions, please put them in Slack or in the chat, and we'll give you some feedback there as well. All right, I think that's it for today. So yeah, see you on Thursday.
Bye-bye.